his name again. Let me see. Do I have to add Pak Devi? Devin Dermawan or Pak, who's his name? I think I have to add one of you to be my co-host or something. Pak Devin, yeah.
I am, sir. Yes. Muhammad
Oh,
Denandi.
Denadi. Denadi. Where
But
is
I can still cannot record the meeting.
Oh, you need to record the meeting.
Yeah, even
Oh, you start your name with M. That's why I cannot find it. M.
MD
Okay.
tadi.
Okay, I will add as co-host. Anyway, so I record the meeting myself using. I'm not using the Google Meeting recording facilities. So I have my screen recording tools. Yeah.
Nah, thank you,
So
sir.
I hope my recording is okay for today. Anyway, uh, okay. If you have any question, feel free to put it in the chat box. Then I will go. Oh, okay. Welcome. Feel free. Okay. Now, I will try to discuss about the forecasting very quickly. I did discuss it yesterday in the last meeting. So to make things, so basically, we need to create the data, training data, and then creating the model, and then creating another data for forecasting, and then we can forecast something. Okay. Uh, the data itself, the easiest way we can build our own data. Where is it? Okay, this one here. I think I have to open my. Okay, so for example, we have this miskin.xl, and then this is the one. Okay, so we have income, education, uh, time in education, house, motorcycle, car, kids, uh, uh, loan, name, classification, stunting. Okay, depending on which target you want to forecast, either classification or stunting. These two are okay. Some of you send me email asking how can we decide if we see a data like this, how can we decide which one is the target? Okay, you can use we can you instinctively normally I use the label from human label as a target. So this classification and stunting is basically labeled by human. So these two can be used as target, either classification or stunting. Name is not good for labeling. This is good for information only. The rest is maybe this is like an organic parameter built into the data. So the organic parameter is I'm not normally use the organic parameter as the label as the target. So I will normally use this organic parameter as my feature. So these are feature. These two are targets. We have to select either classification or stunting as target. Of course, these two can always be used as feature as well if you like. But I normally use this as my target. Okay. We can use income as target as well if you so you can play around with it. But I normally use income as my feature. The rest will be these two only or as my target. So having said that, so I already run the orange here. I think I have problem with my orange because So I play around with the text facilities. I think I have problem when installing the text mining and taxable facilities. So I have problem in text mining and the taxable, this one, taxable and text mining. Some of the function doesn't work properly. Okay, give you some. Or maybe later I can show. Okay, so we can read file using this, and then we can read miskin. Okay, and then we can check the data using data table, and then we can see the my our actual data. There is no target yet defined in the data, but we have 10 features, one meta attribute which is name, and we have 37 instance. 37 instance considered very small. Okay, normally we have thousand of instance. Okay, so we have the data like that, and then we can select which one we is used as our target. This is classification as our target. Stunting is ignore. The meta will be name. Okay, the rest is feature, and then we can fit the data into model. I think one of the good model to do these things maybe random forest. I normally use random forest for this kind of data. If you like, you can save the data, can save the model like this. Okay, so you are welcome to save the model. Having saved the model, then we can use the model later on. But we save. We need to define the file name first. We can save as something, so we have to define the name of the model, if you like. Okay, so we can save and define, and then we can save the model. Having the model ready, then we can do prediction. Here, prediction. In prediction, we need to get we need to fit the model into the prediction widget, and then we need to read another file with similar structure. The structure must be the same. So this one is different in penghasilan. Let me check. Let me see the difference. Sorry. Okay. This is the first data. And then this is the second data. Let me see the difference. We can close this one so I can see as many column as oops, I can see as many column as I can. And then let me see. Okay. So this is the original data. So basically I multiply by 10, 10 times larger. So I increase the income to 10 times. Oops, how come this one is not changed? This is unfair. So this is increase, increase, increase. Uh, 17, 1, 2, 3, 4, 5. 17, 1, 2, 3. Oops, this is only one is change. This is change, 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 change. This one the same. Oops, this 1, 2, 3, 6, 6. This is 6. Oops. Okay, I think I have problem. Okay. Uh, okay, I have to cheat a little bit. Okay, I will file, save as this one. Okay, Now I have to change. Uh, I add 0 here. I think I should be able to do it more efficiently. Oops. Okay. Okay. I multiply by 0. So this is as government office or planning bureau in government, they can do something like that. This so we can increase the certain parameter and see what happened to the classification obtained from. Okay, so I increase 10 times, all of them 10 times. So I increase all income in by 10 times. Okay, save. Okay, okay, let's reload. Reload. Okay, let us see. I think this one is much better now. Okay, this is 1, 2, 3, 4, 5, 6. Okay, so this one is 10 times. Then this one, see what happened. We have to select the same column. Oops, sorry. Okay, and then we can fit the data into prediction, and we can see what happened. So one change, this one is not changed. One change, this one change, and then this one, 2, 4 total, 5, 6, 7. Whoops, this is wrong. Okay, and then this one 8. So we have around 8 or 9 chains out of 37. So in total, we can claim using by adding uh, by increasing the income uh, by increasing the income by 10 times, then we can have like 8 out of 37. It's sorry, not multiply. So we have what 21% increase. Okay, change the status from one status to another, but increasing status. So basically, we can claim something. So this is the finding. This is the reason for forecasting. Okay. Any question at this point? Can you share your so we can use it in practice in Orange? Okay. I will. You can build your own if you like. Now, how can I upload? Can I upload here? No. Okay, I will send by email then.
Thank you, sir.
Okay, you're welcome. Okay. Now I have to check the uh I will send as many file as I can. Okay. How come I can click new message? Okay. Uh Okay, I will try to send as many files as I can. Let me send this one. I will send. Where is this miskin? Miskin. Will send. This is only what 17 byte. This one I can send. This one I will send. Uh, so you can play around with it. This is weather, and then another weather. Oh, this one the animal. If you like to play around. Okay, we have penghasilan. We have where is it? Prediction. So you can play around with this. I make program number one, program number two, program number three. This is meaning the example program for the government. Okay, I forgot program number one is what. Maybe we increase the income. Program number two, maybe we adding more houses for each person, something like that. So you can play around with this. Number two, number three, and then number, where is it? Four. Okay. Okay. Whoops. Should be okay. Or I can send it by my Gmail account. Otherwise, Google will suspect me as a spammer. Okay. It is sent. Okay. Now, so basically, we can do something like this with other data. For example, oops, sorry, wrong. I think that's okay. I will read uh, program number one. Let's see what happened. Okay. So what happened in program number one? Oh, I think I add uh, in the first uh, in the previous file, I multiply all income with 10 times. In this one, I add what 200,000 for each income. So this is basically I increasing the income, but adding a certain number. Let me see what is program number two. Program number two. I think I add which one I add this one. I forgot. Oh, I think. Oh, this penghasilan as well. Nope. I know. I forgot. Let me see the difference. I think I add the number of years here. Let me see if I correct. No, no, I forgot what is program number two. So basically different program, different variable, and then we can evaluate which one is best from budget point of view. So if we add this the income, how much budget we have to spend. If we increase the education, how much budget we have to spend. From that kind of point of view, then the government can decide which program they will pick to change the status of the people. That's it. Okay. Now, okay. Now let me see if if I miss something. Okay. Okay, so I've shown you how to basically to create the testing data. We can use Excel. The actual data in the government planning body, many of the data is in Excel form, so we can use the same data. And then you already seen the test score and algorithm. We can save the data and we can do forecasting. Basically, all the material we need for this meeting has been covered. But we can always play around with different models, different data basically. But the ID is the same. Now, because many of you are playing around with text, I think I will shift the material for today into text analysis. Okay, because many of you actually have to analyze text, not only what's that? Not only numbers. I need to tell you how to analyze text. Uh, we can. Okay, I will close this one. Okay, I will remove this one. There are several type of text. It We can have text as variable in the data. For example, this one. I will choose the data set with text in it. Let me see. Car evaluation here, including Titanic. You remember the in our first meeting I showed the Titanic, and then it has text as the variable. So we have this kind of text. This is not the whole sentence. This is only text as a label. So the treatment for label and sentence is different. Okay, so if it is label, we can treat the variable, the column as very similar to numerical values. Okay, so if it is label, if it is sentence, then we need to use the text mining or textable widget. If it is only label like this one, we can treat this as similar to variable, so as number. Okay, because this is only label, so we can treat the variable here similar to numbers. Okay, did I have I used this? I think I already show you this one, right? I forgot. So, so basically, this is how to select a car. So we have unacknowledged. That is acknowledged. Acknowledged means someone will buy the car, and then the buying price is very high. High. We have several variables. High, very high, high, and we have 1,728 instance. So this is peak actually. Very high, high, medium, and low. Okay. So the buying the price can be very high, high, medium, low. The maintenance cost can be very high, high, medium, low. Number of doors two, four. Number of person two, four, and more. And the luggage small, big, medium, and then the safety low, med, and so we have this kind of text. Basically, what we need to do is check first check the algorithm. Let me see. Okay, we have one target with four values. So this is the target. Car is the target. It has four values. So basically, this is like a classification problem. So we have target car, and it has four value. We have unacknowledged means not uh, not okay, 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 and then what else? Mostly okay and not okay. Looks like two. Does it has other than that? Oh, this one. Good and very good. So we have good and very good, and then an ACC and ACC. Okay. Now we can test several algorithms to do these things. We have logistic regression. It's normally used for classification. We can use tree. We can use random forest. We can use gradient boosting. Many things, and then we can test which one is best. Okay. Now, oops, 19 minutes. Gradient boosting is very slow. Basically, tree is the best. Random forest is close to tree. Gradient boosting is the best. Okay. Of course, we can always change the parameter here. So we can change the parameter here. If we increase the number to trees, it can be more precise, but longer time to process, basically. Okay, so we can change the parameter here if you like. If you don't, I personally normally my preference will be random forest, but in this case, gradient boosting seems to give a better precision. Okay, now, but for to get the result quickly, I will choose random forest. Okay. Now, uh, eh, no. Don't use random forest because I want to see the decision tree. So I need to use tree because I need to see the decision tree. So I need to use tree. Then, because of the use of decision tree, we can have three viewers. Okay. Now, so three viewer with only will work only with three algorithm. So tree viewer works with three algorithm. So if we want to see the tree viewer, we need to use tree as the algorithm. Then we can see here. See, most people will select the car based on the number of person in the car. They prefer four or more person. If it is only 2 person, they are not preferred. And then after person, they will check for safety. If it is medium, if it is low, it's not preferred. Medium in and high is preferred. And then after that, we see the price. After price, then maintenance. After maintenance, then we can see the luggage. Okay. Uh, or this is safety and back to safety again. So basically, stop the maintenance and luggage here. Okay, so that's how this is the decision tree. Okay, so this is important. If we have a table with many features, then we can tell which features will be analyzed first to do the to get to have to get to a decision. Then we need to decide which feature is used first. In this case, the number of person in the car will be used first. This is the first features we use. Then we can use safety, and then cost of the car, and then the maintenance. If we see a table, then we have to think. Not all the feature will be used for decision. So we need to analyze which feature will be used for decision. This is how we do it. Okay. So it's very simple like this. And we can see which one is used for the decision process. Okay. This is important actually uh, for CEO, CIO, for leaders, for managers. So all of this guy have to decide on something. But if to be able to decide safely, then we need to analyze the data and check which one is actually the most important feature in the data. So using this kind of approach, we can see how people actually do these things. The same thing if we analyze the Titanic. I just gives you some reminder about, okay, where is the Titanic? Be this one. So using Titanic, we can see sex will be number one for decision whether you will die or not die. Yes is die. Yes is live. Mean okay. Yes is live. So uh, female will likely to live. Male will likely to die. And then in female, we can see the status whether if you are a third class, then you will likely to die. If you are a first class or second class or crew, you will likely to live. So third class, if you are uh, don't have enough money, you will die. This is in a ship in Titanic. And then if you are old, you will die. Adult die. If you are kids, you will live. And then how? So this is how the decision for dying is decided. Sex, status, age. For female, for male, sex, age, status, different. Okay. Okay. So that's the. This is not prediction. This is basically decision support system. Okay. Now we are at 7 o'clock. If you have any question, put it in the. Okay. How to determine the best method for prediction? Do we need try one by one some regression method, then prove the best model? Evaluate. Do we have to identify data set first? Decide best method. Okay. The when we need to decide which method or which algorithm is best for certain data, we need to test using test and score. That's it. Okay. So we use this one. Okay. Now, as I showed you earlier, to use this one is just feed the data into test and score, and then feed the algorithm into test and score like this.
I'm sorry, Pak Ono.
Yes,
Your presentation is freeze, I think.
freeze. Wow.
Yes.
Okay. I think I have a problem with. Okay, I will stop sharing and then share again. Entire screen. Okay.
Enough long time, Pak Ono. Maybe you will repeat from
Oh, it's
from
really, really.
15
Wow.
minutes ago.
Wow. Okay. Okay. Uh, Let me see. Which one? I think someone have to shout. Terima kasih, Pak. Okay. Uh, when was my last time? Let's see. I have to remember. I show this data set. Is it freeze or not during my presentation about the data set, this curve evaluation? Is it freeze at that time? Let, okay, I will repeat from this curve evaluation and also answering the questions. So basically, okay, so the questions, okay, the question is how to determine best method for prediction. Okay, do we need to try one by one? The short answer, yes. You need to try one by one. Okay. Now, how can we try one by one? By doing this one, test and score. Okay. So we need to feed the data set into test and score, and then we need to test which algorithm will give you the best prediction, basically. For each data, normally we will have different gradient boosting will take longer time. Okay, 20, 40%, 40, 50%. So, so we are interested in the this one, the prediction, precision. Okay, precision means how precise the algorithm can predict. Okay, so of course we need to select the one that gives the highest precision. Okay, gradient boosting at this point will give you 98% precision. Of course, we can play around with this one. The cross validation, random sampling will give you different results. Okay, okay. But normally this one is okay. Then I have to wait again. Okay. 64%. Okay. How about random sampling? So we can play how many times we can repeat train and test things, and then how many percentage of the data set used as training set. We can change this one. So we can play around with this, and then we can have some feeling about our data. Okay, and this one same gradient boosting will give you the best results. Okay, but gradient boosting cannot be used to show the decision tree. So if we want to have a decision tree, we need to select three. Okay. Now, for different data set, will give you different results. For example, this one, breast cancer. Okay. Okay. Uh, so in breast cancers data set, we can see the precision. We can only get up to 68, 68 something percent. And logistic regression and random forest will give you a best results. Gradient boosting is not good as random forest. We can always change the variable of the algorithm by changing this one. Okay, so we can always change this and then see what happens. If we want to compare one algorithm but different variables, we can do something like this. So we can have two random forests. Okay, okay. But this one, we change for example, we change the number of trees into 20. So hopefully it will give you uh, a better results. Hopefully, I don't know. So we have two different random forests, one with 10 number of trees, and then this one is 20 number of trees, and then see what happened. So we have number forest one, see, it's increased. Okay, so with one algorithm, we can create the same algorithm but different parameter. We can have different models like this. Okay, so we can check which which parameter will give you a better results and compare to the other one. Okay, so for example, I want to evaluate only sorry, one variable like this. Okay, so we can have one algorithm but different variables. We can change around. uh, See, this is numbers forest 2, limited individual tree into 5, for example, give you a worse result, I guess. So this one is not that bad, but I think this one is best. That means we can increase the number of trees that, but we need to add more CPU time by increasing this. Then we can have better results. Oh, okay. Let me see if I can change this one. Okay. The random forest 2 is 50, random forest 1 is 30 or something. one is 30. See what happened. Only slight increase, but this one is sort of the maximum we can get from the data. So that's how we play around with the parameter, internal parameter of the random forest, certain algorithm. Okay, hopefully that will give you some idea. Uh, so it's very depend on the data set. Different data set, different model, different parameter. So it's very different from for different data set. The problem is, okay, the uh, okay, oops, sorry. The problem is, let's see. Okay, if we see the data set like this, the problem is the data set we see here is basically static data set. Is fixed. If you can imagine a government office, the data set is not static. It's it's changing. Every year we have different data set. Every year we have different activity in the people. So actually the data is changed every year. So every year we need to to train the model. So it's not as easy as that because every year the data set is different. For especially for government office, okay, the data set is different every year. Okay, but to play around, we can use a static data set first, and then we can change the data set. Having said that, uh, Orange have this capacity here, time series. Let me see if I can play around with time series. Let me see if I have example in time series. Text prediction, auto prediction. No example in time series. Okay, anyway. Okay, so in time series is, for example, the price of stock market. So we can have price of this is Amazon from 2019 to 2024, for example. We can download the fail. I cannot access the Yahoo Finance. Okay, okay, yeah, they are not allowing us to download now, so they block this one. But basically, in time series, we need to we can, but we have no other sources. Our source will be Excel file now. Just to give some idea, it has the so Orange has the capacity, that has the ability to predict time series data. So, for example, Yahoo Finance, we can have stock market, or we can have if it is economical data, we can have what's the let me see what's the type of economical data uh, time series. Okay, uh, we have uh, financial data. Let me the type of data. So GDP. Let me see. Basically, we have like economical data. We have what? Uh, in the bank, we have. I'm not economist, so I'm not good. uh, oh, this one. See. Oops. Uh, so we have this one. So we have stock price,
interest rate, exchange rate, other economic variables. And these variables are time series based on time. So we can get the Excel file based on this economical data. Then we can predict using. So we can, this one is Yahoo, but now we need to load the data using Excel or something. Okay. Now, having the data, but this one we don't have data because we have no longer Yahoo, I think, closing the access to their data. If we can access the data, then we can have several model to predict time series, ARIMA, FAR models. But from my experience, this time series type of data, we can only predict like very short distance. For example, if we have monthly data or daily data, stock market data, we can only predict like 1 or 2 days in in advance. That's it. We cannot predict like 1 month or 1 year. It's nearly impossible. So yes, we have facility to do prediction like that, but it's not as easy. It cannot. We cannot predict for far, far, far in the future. So we cannot predict that far. So we can only predict like 2 days from now, or that's it. Okay. So yes, we have this. Now, normally in time series data, this is how we cheat basically. uh, this is what happened with the Bank Indonesia or OJK. So they need to analyze time series data, but this time series data is not about stock market price or interest rate. This time series data is more on the transaction, who transfer a fund to different account. So they need to monitor that kind of transaction. Basically, they need to monitor any fraud in the transaction. So what they do when do they analyze this data like that, they are not using these facilities basically. They actually take snapshot of the transaction. Okay, this to give you some idea only. So basically, all transaction, money transaction in Indonesia is time series. Okay, this hour, this date, this hour, how many rupiah transfer from one account to another account. So they have that kind of data. Uh, Normal. So they have a normal transaction, and then if there is huge transaction, it's not normal, then basically outliers transaction is not normal, and then it will alert the person in OJK or in Bank Indonesia, and then they will alert the bank to stop the transaction. Okay, so they do like that. They may, I haven't used this. They may use this kind of moving transform sliding windows and something like that. So they may use something like that, but in the real, the much simpler method, basically they snapshot every like 5 minutes or 10 minutes. They snapshot the transaction every 5 minutes, and then compare to the average transaction every 5 minutes. If it is similar, then it means it may be normal. If it is there is if there is a spike in the transaction, it may be not normal. Then they have to alert the different bank. So they basically change the time series into static transaction, but different time. Okay, so that's how they do it. Okay, that's about time series. Now I move into text. So we have text mining and we have taxable. Okay. I think in the example we have something about text as well here, but this is more interesting. This is the I have problem with my uh, taxable uh, widget, so it may not work, but I hope it's this one is working, but this one is not working. Let me see the author prediction of tweet. Okay, this one is author prediction of tweet. So we have corpus. This is 2016 tweets of the election in US, not in Indonesia. This is the tweet in US, and then basically we can see the data, the corpus. Corpus is basically Excel file with text in it. So this is Excel file. So we have the author Hillary Clinton or Donald Trump. So they have two authors, and then this is the source, and we have the content. So the content is text basically, uh, and then we have original author, place, tweet, retweet, true or false. We have time, English language, retweet count, favorite count, and then coordinate, longitude, latitude. Okay, so we have that. Let's see if what kind of things we can play around with this kind of data. Okay, I I really hope the 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 there is no problem with my, but I know I have problem with my text mining and taxable module. Okay, so we can always make a model out of it, or we can always, uh, what's that? We can always play around directly from the data we have. So this is the, I will remove this. We don't need this one. Okay. Oops. Okay. Okay. So this is the data, and then I move in. I feed the data into pre-processing for text. Basically, in pre-processed text, we can transform all the text into lowercase. We can remove accents. We can parse the HTML. We can remove URL, whatever. You can click all of them if you like. Okay. So we can make all the text into plain text, and then we can tokenize the text based on word punctuation, white space, sentence, or tweet. Because we are dealing with Twitter, with tweet we can tokenize the text based on tweet. We can filter the stop words. Stop words is the words connecting different ID. For example, words that have no meanings. For example, it has no meaning. It has no meaning. It has no meaning. So that kind of words we can remove. So we can remove stop words, we can remove number, we can remove slash, comma, so on. We can remove. So we can remove this. We can we can feed only the most frequent tokens, how many most frequent token, and we can play around. So we can pre-process basically the text before we do the actual processing. If the text is too much, too many text, normally we can select most frequent tokens. Okay, if you so this this one most frequent tokens will reduce the amount of work because we will analyze only 250 or whatever you can decide. Okay, now so we can play around with this thing. Okay. Now, close this one. Now, back of words is different. Back of words is like this. Basically, uh, it will count. In back of words, basically, we will count how many words for certain words. For example, uh, let me see. Let me show the data first. Okay. Okay. Let me see the content. So for every single content, every single words, it will count. How many question, not how many questions. Yeah, how many question word in this text. So this is one. I don't know how the other. And then we remove we remove in normally. Who is not removed? Who? So we have one who. We have one question. We have one election. One who. One plans, and so on. So basically, back of words, we calculate, not calculate. We count for each words how many. Okay. So based on that, basically, it will create a database. We can see it as database with word and number and frequency of that particular word. We can visualize this as coordinate or uh, coordinate with many axes. So the word becoming the axis. Okay. Now we can visualize this, the actual sentence becoming a factor. Okay. So that's how we measure this thing. The same thing is the same process is happening with LLM. In large language model, we actually do the same thing. Okay, so we will tokenize its words, and then we will measure how many times it appear in the text. And normally we save this in LLM, in large language model. We save this into factor database. Okay, that's what they call it. Basically, we transform a text into factor. Okay, factor basically it has coordinate in a factor. Okay, but the axis is the word becoming the axis of the factor. Okay, so that's how to visualize this thing. Now, okay, so we have this kind of data. So we have this kind of data. Uh, we can see, we can measure which what type of text is favorite, what type of text will be retweet by most people, and we can see the longitude and latitude for certain text. I really hope the the widget is working. We can use that data sampler if you like. This is make the data becoming smaller. So we take sample of the data. This is only 20% of the data used as it's sampling 20%. Okay, if we want to minimize the process. For example, I want to see whether I can do something with small number of data. See if I can. Ah, see, it crashed. Okay, I think I have a problem, so I cannot show this. Let's try again. I think it will crash. Crash, crash. Okay. So basically, if it works, if it doesn't crash, we can feed the data here. Okay, but it doesn't work because this one is crash. Then we can have the word cloud. Okay, word cloud is something like this. word cloud, so we can have this kind of image basically. Uh, it can visualize which words what no 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 it can visualize the way it visualize the data. It increase the size of font depending of how many times the counting of this particular words. If it frequent, the size will be bigger. If it is not frequent, the size will be smaller. Based on that, we can see which word is the most frequent use words. Okay, that means we can see uh, what issues is dominant, what kind of issues. Okay, but sometimes certain issues has two or three words. Okay, if we have that kind of situation, we need to analyze that with different methods. So this is if the issue is only one word. One word is easy, so we can use word cloud and we can see the issues by calculating number of time it appear in the text. Okay, if it is frequent, the font will be bigger. If it is less frequent, the font will be smaller, and then we can see what kind of issue is uh, is discussed in the text. Okay. Now, if it is if one issue have different have correlation, if one issue have two or three different words, then we need to see the connection, the network of the words. Okay, for example, so this one doesn't work. Sorry, my OS is not installed properly. We can uh, change the corpus into networks. We can fit it like this. Oops, sorry, it is too many. I will change into 250 most frequent tokens, or maybe 100 most frequent tokens. Okay, so I will use this one to make the processing faster. Okay, it, it will calculate first. Okay, let me see if it can calculate correctly. I will remove this one first. Remove. Okay. Okay. Now it's finished. Now I fit this here. So I have only 100 token fit from the pre-processed text into corpus network. Using this kind of method, we can see the relation from one word to another. So one word is correlate to which word. Okay. In word cloud, we can only see the number of times the most frequent word used in the text, but we cannot see the context. We cannot see the correlation. Using the network, we can see the correlation. We can see the context of these particular issues. Okay. Uh, well, 21%, very slow, eh? Okay. If we have the network, then we can, so basically we use corpus to network to generate the data from corpus into network, and then we can visualize the network using this one, the graph. This is basically graph, not graphics. This is graph. I have to tell you something about graph network. Okay, so basically we will see something like this. Okay, so it basically calculate, uh, and then it will calculate how many times this connection happens. Okay, now so we have vertex, we have edge. In graph we have that, we have vertex, we have edge, and then if the algorithm is good enough, it will calculate how many times this edge is happening. Okay. Now, the more normally when we visualize a graph, more frequent edge will be thicker. This will, if it is more frequent, this one is more thicker. If it is less frequent, this particular edge will be thinner. Okay. Then we can see, okay, this is important. This is not as important as this one. So we have two words, we can do something like that. Okay, this is very important. This kind of visualization is very important because we can actually see what happened in the text. For example, this one. This is one example. Drone Emprit. Uh, we can see the this is the fightings between uh, pro Anies and contra Anies. So we can see this is from Twitter basically. Okay, and we can see the fight. Let me see. Let me see if I can show you something. Okay, this is the bad guy. This is me, and this is Ismail Fahmi. Ismail Fahmi is the one who wrote Drone Emprit program, and then we can see this on big screen like this. Okay, Ismail Fahmi was my student, so he did his undergraduate under my supervision. Okay, so this is the example. This one is hashtag with hashtag turunkan Jokowi. This one with hashtag Gejayan memanggil, and these two uh, front fight with one another. Oops, 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 oops. So, oops. Okay. So we can see these two front fight with one another, and we can see this one is from Twitter basically. We can see these two front fight with one another. We can see the interaction here. This one fighting with this one. One read with one answer and so on. Both has buzzer. This one is actually buzzer. We can see buzzer. Buzzer is not uh, buzzer is not normally react to other uh, postings. If it is human, normally it will react to other postings. Okay, so when this reaction is by human, if it is buzzer, it will not react to others. So buzzer is like this. So we can see who's the buzzer. So this is the actual buzzer. This is the actual buzzer. This one it has many buzzer. Gejayan memanggil has less buzzer seems. Okay, but this one has more people actually. But from the text, it seems uh, so turunkan Jokowi is not student. So this is more robot. This one is more student. So we can analyze something like that. Okay. Okay. Let me see if this one finish. Okay, this one finish. So we already have the network here. Let me see if I can visualize the network. Let, we can network explorer. We have network analyze. We can play around with this one. Okay. Oops. Okay. Okay. Let me see if I can. Number of node. Now we can explore. So we can. Oops. Okay. It need to. Oops. It's hang. Okay. Orange is not responding. Ah, okay. I think I have a problem. Or I already changed the processing into 100 token only. Okay. So this is the layout. The network is too large to visualize. Okay, thank you. I think I have to reduce again most frequent networks into 20. Okay. So, oh, worse. Let me see if it is. So we have play around with the parameter here. So the node type is Word. I set as document. So I'm wrong. So I have to change it into Word. So I have 450. Oh, so we have 62. I hope this one is. See, we have this. Normally it gives the node size. Uh, show legend. There is no legend here. It's becoming only 11. But there is no legend. How come there is no legend? Uh, or label. Up. No label. I need the label. Or the label not show up. So basically, if I did it correctly, each node will be labeled uh, as words, and then we can see here. These two is frequent. This one is a little bit frequent. The rest is not as frequent as these two. Okay, so but I lost the label, so I cannot tell more than that. How can I get the label? Oh, this one is not as good. Uh, Let me see if I can get label here. Nope, no label. Okay, I have to look for the label. So yeah, you need to play around with this. Let me see if I can 100. Okay, how can I get the label basically? Oh, sorry, I have to recalculate again. Nope, same. Okay, let me see if I can get the label that way. Nope, I'm not getting any label. I think I'm in trouble. No, no label, no label. Okay. So, if it is correctly done, I can get the label. No, no, it doesn't show any because there is no label. So I'm in trouble. So, okay, we play around, relay out. Okay, so basically I don't get the label. If I can get the label, then it will be more fun. So we can see what happened here and so on. So I don't know where I can get the label from from the tweet, or I change the corpus. Okay, for example, I can change the corpus into Anderson. Anderson is the book from uh, kids. We have Ugly Duckling, Philosopher's Stone. This is the uh, Anderson books. Okay, let me see if I can get something. Let me see if I can get no label. Same, but this is the graph we can get. So I have to play around with to get how we can get the label here. If we can get the label, then we can see the relation from one to another here. Okay. Uh, I did programming this manually using Python. I think 2 3 years ago. Like this, we can see the label here. So there is a label for each node. Okay. Uh, if we do it manually, if you like, I this is my book actually. Ups and the publisher. Okay. Let me see. I can get the book. Where is text mining? This one, text mining. So yes, but this one using Python. There is no orange here. This is Python only. And on this one, I show how to analyze the text and then labeling the node, and then we can show the actual graph. Okay. It's good to be able, if we can use these things, then we can see how strong is our brand, what the reaction of people to our brand, and so on. Basically using text mining. Okay, so in this one, in Orange, it has the capacity to do text mining, and it has the capacity to do the graph and networking and so on. But the problem is, I need to I I need to be able to correctly set the pre-processed text and so on to get the label. Uh, Let me see. Well, you can. I hope you can play around. Basically, the aim is to get the label and see the what's that, the graphic with label. Then we can we can say something about our data. If there is no label like this, then we are in in trouble. Whoops. Okay. How about if we feed it directly like this? Can you? So this is direct. I hope I still can get the label by make a direct connection between corpus network and then visualize, explore the network. Nope, no label. Oh, yes, there is label. Oh, okay, okay, okay. Let's try on our previous data. Election tweet, content, reload. Okay. Uh, Let me see. Okay. No type is words. We have 120 words. Okay. Now we can. Okay, this is too many nodes. I think I need to remove some of the nodes by reducing the number of token. For example, this one. So we only analyze 30 most frequent token, and then we can Okay, this still too many. Uh, okay, let me see if I can reduce it. Okay, I only show the most frequent one. 10, 40, 20. Okay, I hope it's okay. So, okay. Let me change a little bit. Oops. So we need to play around with the variables. I hope I can get something. Okay, we can see this is about this word is frequently used. Donald Trump, and it has have relation with Hillary, and Hillary have relation with president, and president also have relation with Trump. Okay, so this is how we see these things. Okay, I did some experiment. Let me see if the text still exists here. Kompasiana. Let me see my if my text still there. That has been long time ago. Uh, okay. No. Can I do something like this? Nope. Uh, oh, okay. Okay. Now, this is the text. This is the result of my coding, this one, from this book. So I use this book. I am not using orange on this one. I use this book. And then this is the example of the results. This is about the election in Jakarta 2017. That means what? 7 years ago. So basically, I analyze the text of the from news, text news, 7 years ago using during the Jakarta election, and then this is what happened. Okay, let me see if I can. So this is the example of the text. This particular text is okay. It's not seen clearly now. Wow. They changed the they changed the okay, they changed the labeling become it's This is wrong actually. Wow. Okay. So in the original text, I'm not saving the original text. I don't know. I think I'm not saving the original text. Let me see if I have it here. But I think I'm not saving here. Uh, Text mining. Sometimes I save my text here. Uh, Let me see if I can get something there. This is the method. Nothing to do but text. Okay. Uh, but this is wrong. This is not correct. Someone changed the graphics basically. So the original one, when we analyze the text from the news during Jakarta election, if I use Ahok, then the graph will show Ahok, will show pengadilan, will show that kind of stuff. So yes, Ahok is strong, but but the other words connecting to Ahok is not a good words. We understand during the Jakarta election, Ahok were then jailed uh, by the pengadilan. So we can see actually from the actual text. So the actual text is not this one, the actual graph. So someone actually changed the graph or something. I don't know, but I'm not saving the data, so I cannot show you. And this one, uh, oh, this one is the text from Anis. No, ah, they changed many things. Uh, so when it should be like this. So I use Agus Silvi, Ahok, and Anis as keyword for searching news in the media during the Jakarta election. When I use Agus Silvi, the the most word used in the text is actually Ahok. This. So this is not so the I use Agus Silvi as keyword, but when I calculate the text, it show Ahok more frequent. It means Agus Silvi actually attacking Ahok, and Ahok words is uh, the frequency is very frequent. So the Ahok word is big like this. The and then uh, it means the branding of Agus Silvi is not as good as Ahok. So we can say something like that. When when I use Ahok, then I can see Ahok is very strong. That means his brand is very strong. Unfortunately, there are several words is not a good words. For example, words pengadilan, words in Islam, something like that. That's actually creating problem for Ahok. Then Ahok goes to jail because of that. Okay. Okay. When I use Anis as the words, and then actually, see, this one is wrong. Actually, Baswedan is the most frequent word, frequently uh, mentioned word in Anis. So actually, Anis is under Baswedan. So Anis is not. So normally Baswedan is the most frequent word shown when I use Anis as keyword. Okay. So based on that, we can see what happened. We can predict what happened during the election. Okay. So I use this one. So orange has that kind of capacity, this kind of capacity, but uh, we need to change a lot the parameters to be able to get the most of the this. Okay, this is Trump, America, Hillary, Trump, great Trump. So we have to uh, to be very slowly. So, okay, this one America great, make America great. So this actually most frequently used word as well. Make America great. Okay, make America great. So this another word that frequently occur in the tweet and this one also. So we can play around with this. So the remember the code is like something like this. Okay, let me see if I can do something like this. Okay, what happen if I move it like this? Can it show something different? Okay, similar. Okay, so I can fit the back of words directly to corpus of network. We can pre-process. We can uh, regular expression. We can split the text into words. Okay, here what happened now? If I can split the text into words, see what happened here. Same, not much different. Make America great. Hillary Clinton in one side and then Donald Trump in other side. So we have Hillary Clinton, Hillary Clinton, and then we have Donald Trump, and then we have make America great. That's the keyword during the in the tweet uh, during the election. Okay, we can do the same thing. Let me play around with other data. Let me see if I can change this data into Anderson. This is AC Anderson. Uh, most only 30 most frequent tokens. See what happened here. Beauty, even, F away. Okay, let me uh, give more 80, for example. What happened here? One said good, beauty, poor. So it doesn't make sense. But we can see how it calculate things like that. So we need to play around with these things and then see what happen. Of course, we can always use different language. We can use Indonesian language here as corpus. If we have a text, not corpus, we can do something like this. Uh, for example, we have I have text here. Oops, sorry. Uh, I have a file called 10E Strategy 2024. Okay. There's a file like this. Okay. Of course, I can always use ChatGPT. I can do something like that to ChatGPT. Let us compare between ChatGPT and Orange. Oops. Start now. Okay. So the text is this. This actually the actual text is I grab it from news, okay, and then I ask ChatGPT to create a summary of this 10E strategy from the following news. Okay, so I can do something like this with ChatGPT. Okay, so we ChatGPT is easier to use to analyze text. So we have five major strategy in our armed forces. focus in defense, neutrality of the armed forces, uh, security operation, synergy and collaboration, and education. So these three is detected in the text. Can orange do the same thing? Okay, this is much easier using large language model. Can this orange do the same thing? So we need to remove this one. So basically, this is corpus because our file is text file. So we need to go to textable. Sorry, this one textable. Sorry, this is text file. Okay. I need to browse and then orange and then this one. Okay. This is the actual file. It's sorry. Ah, crash. Okay. It crash. Doesn't work. It crash. Okay. If it doesn't crash, okay, well, okay, crash. So it's sorry. No data sent to output yet. Clear. Click send. Crash. Okay, I have problem with the Python of Orange. It's not installed correctly. If it's installed correctly, this one doesn't work. So so if it is working correctly, then we can do something like this. So we can read a text file, and then we need to change a text file into corpus. So what we need is where is the conversion text file into corpus? There is URL preprocess context. This one interchange. So interchange is to change the text file into corpus. Basically, a corpus is a text file in Excel. So basically, corpus is a text file, but in Excel. Okay. So I think we can build a corpus using Excel file, but we have to save it into CSV. Then we can, or not using comma, but using tab. Then we can save it as corpus and read as corpus. And this one doesn't work, so we can move this like this, text file into Exchange, but this one doesn't work. So I remove. If we already have corpus, then we can feed the corpus into here. Okay. We can feed the text mining corpus into uh, pre-processed text, and then we can do the rest, and we can analyze the graph using Network Explorer. Okay, so that's how we normally do it. But this one doesn't work, so we cannot. Nope, no, it's just loading, and it doesn't work. So we have to I don't know, I have to reinstall again Orange and hope this one working. Sometimes it doesn't work. So at this point, is there any questions? Let me see the chat box. How about if we create a data set or combining ini this is a question from Pak Adian Syah Putra. How about if we create the data set or combining data, for example, predict trade flow? There are several features on trade data. I am a bit confused. Which first create data set or decide the method? Decide the method, then adjusting the data set. We can do both ways. There is no no single rules. So we can do both ways. You can set the data first and decide the method, or evaluate the several methods. So we can set the data and evaluate several methods, or but we need to understand for each method, basically, it has plus minus for each method. Let me see. So for each method like this, when you have been playing with the data for some times, then you can understand the plus minus for each method. Okay, I will remove this one. Okay, okay. For example, linear regression, we can only analyze linear data. Logistic regression, we can analyze only for, uh, sorry, linear target. This one, logical regression, is for if the target has uh, several not linear values. Okay, it's normally classification target. Then we can use logistic regression. Uh, some of this data can be used for both, for linear target or for classification target. For example, tree, random forest, sometimes it can be used both, but then we need to test the precision, the error. If it is linear data, normally we will see error. If it is classification target, we can see precision. Okay, so precision is normally used for classification target. Error is normally used for linear target. Okay, so we play around with this one. And for big data, very big data, then especially image data, then we can use neural network. But if it is not uh, image data, I'm not normally use neural network. I normally use tree, random forest. It seems like random forest is easily more easy to use, is not consuming CPU a lot, and will give very good, quite good results. Okay. Gradient boosting seems to give uh, good uh, results, but it will consume a lot of computing power. If it is classification, sometimes I use uh, K nearest network, KNN, or SVM. We can use for classification as well. Okay. If we want to combine several methods, we can combine several methods to analyze certain data by using stacking. Stacking is combining several methods. Okay. For example, like this. Okay. For example, we have, let me see if I can, Titanic data. Okay. If we use Titanic data, we can test the data using this one, test score. Okay. Then we can check the, oh, linear doesn't work. Of course, it will not work. In Titanic Titanic data is classification. Okay. For example, we have this and three. Okay. Then we can see it has three give random forest give the best results. Sorry, uh, more precise result from random forest. And then we can stacking several methods here. And then, for example, in this one, I will stack logistic regression, naive bias, and random forest. Okay. Okay. Then we can test this as well. So we can stack several methods together and then see what happens. Okay. This one. stack, uh, still random forest is better. So by doing so, we can we can analyze how how we approach what kind of algorithm we can use to analyze certain type of data. Okay, see this by stacking is not solving the problem actually, so we can still use random forest. Will give you a better results. Okay, so that's how we do things. So this is much quicker to see things. It's quicker this way. Okay, so there are options like this. Okay, let me see if there is any more questions. Okay, the first meeting, to be honest, the first meeting I fail when I record the video. So sorry, I don't have any recording of the first meeting. Uh, but if you like, you can do something like this. You can go to Ono Center. Okay, go to videos, and then there are a lot of video or not videos. Do I have? I need to go to data engineering, data science stuff. So go to Ono Center, click playlist, and then go to this one, deep learning. Okay. In this playlist, data engineering playlist, it has 334 videos in it, and then you can see this one. Let me see the introduction. So it has something about the prediction forecasting time series. So the I'm looking for the introduction stuff, something like this. This is most likely introduction. This is most likely wow. Okay, seriously. Oh, 9 hours. This is in IT Camp 2019. This most likely introduction. So we are guessing which one the introduction. I'm sorry, the our first meeting I fail when I record the class. Okay, so we can see this thing here. So look for introduction, and also this is from my other previous classes, so you can see. And it's not necessary orange. Some of them are using Python, TensorFlow class, and so everything. Okay, for example, this is using Google Colab. So Google Colab is normally Python. Okay. Let me see if there's anything. This is about NLP. NLP is Python, but better use large language model than NLP now. Spider is Python. This is how to install Spider for beginner. What else? So from the keyword, we may know whether it is Python or Orange. You are welcome to see this one is Python web scraping. This is how scraping the web using Python. So yes, you are welcome to see 334 videos. Some of them are for introduction, very similar to our first meeting actually. Okay, so that's the intro. What else? In terms of for the international student can follow to the I feel lost something. Okay. Uh, how many? We have 5 minutes more. I, I can redo the intro. It's okay. Uh, I will answer the last question first. In terms of try to seek most suitable model on bigger data set, is there any method how to simplify the data set before we try to move Python? Okay, normally if we before we process a bigger data, I normally split the data. So I normally use this one, data sampler. You can use Python to do the data sampler as well. So I normally use this data sampler, and I can fix how many percentage of the data will be processed first. Okay, so we can process only 20% of the data, or we can shift this, change this. 72, 70 something, 93%, or that way. Uh, that's it. So we can do something like this. Okay, data sampler. So, and then we can generate the data. Uh, but remember, some of the uh, some of the model will be different between uh, 20% sample and 90% sample. So we need to check every time using test and score. Uh, what kind of result we can get if the data is 20%, what kind of precision we can get if the data, if the model use 80 something percent. Okay. Now I have 3 minutes. I will goes for my earlier earlier introduction. So in the introduction, I use Google Map normally, Google Map to show between the difference between prediction and classification. So the easiest way is by using traffic. So this is classification type. Okay, so we can see the green is fast. We have traffic jam in red zone. That's classification basically. So that's how I visualize. Normally, when I give the introduction, I use Google Map, and this is how to visualize uh, classification. And then I normally ask how Google can get the data from. So basically, in the process, we normally do spying on someone else phone. Basically, we need to get the data from somewhere, someone. The data normally from intelligent process. Uh, Sometimes legal, sometimes illegal. Okay, so that's the classification process. The other classification process is go to online shop, for example, Tokopedia. This is online shop. Okay, and in the online shop, we can see what's this advertisement, and I normally ask whether every single person have will receive the same advertisement. Of course, all of you will say no. The advertisement will be different for different person, and that's classification again. How the store will classify the person is not, then that's actually the intelligent, how they do the intelligent process, how they spying on us. Okay, they spying on us by monitoring what kind of stuff we buy and what kind of stuff we search, and that's the base of their classification. Okay, and that's classification stuff. And then for forecasting stuff, then we can do something like this: Tangerang to Jakarta direction, Tangerang to Jakarta. Okay, that's forecasting. We can see the condition of traffic now. because we are leaving now. If we change the part at tomorrow, which is not happening, of course it's the same. But if we this is at night, if we change it into sorry, into morning time, 8 a.m. in the morning, uh, we can see traffic jam here. Oops, oops. Okay, we can see traffic jam here in the morning. It is tomorrow, Wednesday, 24th, 8 a.m. It will traffic jam here. It's not happening yet, but Google will predict it will traffic jam here. And normally it is traffic jam. So how can they do the forecasting? Basically, the way they do the forecasting, normally I will ask, how can Google do the forecasting? So they will do the forecasting by analyzing the historical data. And we can see the historical data from here, your timeline. So that's the mindset. Explore your timeline. Nope. History off. Oh, because this is my account in President University. There is no timeline here. My other account, I have timeline. Okay. So basically, that's it. Let me see if I finish. What if this is from Pak Fatur Rahman? Yeah. What if we only have a small data set? How to augment our data set? How to check whether our augmented is reliable? Augment is more difficult. Uh, to be honest, I never done that. But if it is we have missing data, not augment a lot of data. If we have missing data, we can there is option for we can aggregate, we can, but there is no augmented. There is for missing data. So there is an option for filling the select row, transfer group, input. This one. So this one is for adding data to missing data, but not augment a lot of data. So there is no option for augmenting a lot of data here. I have no idea yet. You need Googling or you need Gemini to do those things. So I don't know for augmenting a lot of data. Sorry, Pak Fatur, I cannot answer for augmenting a lot of data and checking whether it's reliable because augmenting is not something what's that? It's not something generic. It's not something part of the data. If it is uh, augmented by human, which is uh, not original, I don't know how can we make it reliable. I have no idea. Ya, Pak Azhar Abizar, is it available for us to export the prompt for Orange into Python language? No, sorry. So there is no option for exporting from Orange to Python. So basically, Orange we will get the ID, the workflow, the mindset, the how the thinking process, and then we have to look for the actual coding in Python. Okay, so for example, this one. For example, this modeling. Okay, so we need to look for random forest or tree or whatever. So we need to the easiest way we use Gemini. Uh, give, oops, sorry, give what that? Give uh, show ran random forest uh, in Python, something like that. So, uh, so basically, this one is reading data. This one is uh, setting which one is the target column and so on. And this one is uh, train set, test. So split between train and test data, train data and test data. This is for splitting, and this one is the actual random forest classifier. So as simple as this one line, okay, but we need to find it. It's not as user friendly as Orange. It is only few lines, but we need to uh, rewrite the whole coding this way. Okay, sorry, it's not as simple as Orange, but you can guess, you can get the ID from Orange, and then you can read the source code and visualize in Orange. Okay, this must be reading the data. This is file reading, and this is for splitting the data, and this is or this one is to select the actual classifier. This one is to train the classifier, and then this one to predict the data using test data. So this one is test data, predict, and this is to print the accuracy. Where is the this one is predict accuracy. So we do something like this. So there is no direct conversion from Orange to Python. Okay. Okay. So it's 2022. We can close our meeting for today. Thank you very much. If you have any question, or oh, I forgot one thing about the exam. I can see here in the machine open course ITTS ACID. Some seems to be working. So you are welcome to use this machine open course, or if you are uh, not 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 secure, you don't feel secure with open course, you are sorry, you are welcome to use this machine as well. Okay, LMS. How come this machine have a lot of problems? So, but it works. It's more stable, but I need to format this machine because this is like 8 to 9 years old already. So it's quite old. The PHP is old. Everything is old. So I need to format this machine. But you are welcome to use this machine, LMS, and you are welcome to use this machine. I will post the your mark in the mail, hopefully tomorrow, so you can check whether you are good enough or you need to do more exam. The exam can be done many times. No, no limit. Okay. Okay. Thank you very much. I will close the meeting for today, and hopefully we can see next week. Thank you. Bye bye.
Thank you, sir.
Okay. Bye
Thank you,
bye.
sir.
Thank you.
Thank you,
Thank you,
sir.
Thank you,
sir.
Pak Ono.
Thank you, sir.
Thank you. Terima
Thank you,
kasih Pak
sir.
Wiranto.
Thank you, sir.
Oke.